Welcome back to AI.Code.Cast, where we love to explore all sorts of coding challenges, and today we're going to be tackling one that looks, well, it looks deceptively simple at first.
It does, doesn't it?
But then when you start to peel back the layers, it opens up all these cool optimization techniques.
Yeah.
We're talking about calculating string scores.
String scores.
And the idea is, imagine you're given a string, just any sequence of characters, right?
Yeah.
And you need to figure out its score based on the differences between the ASCII values of adjacent characters.
That's right. You've got it. And what's so fascinating about this is that what seems like a very basic task, can actually be approached in a bunch of different ways.
Yeah.
And each of those has its own sort of efficiency trade-offs.
Yeah.
It's a little bit like choosing the right tool for a job. I mean, a hammer might work, but sometimes you need something a little more precise.
Like a scalpel.
Like a scalpel, exactly.
And that's what makes this deep dive so interesting. We're gonna explore, different approaches from the very straightforward to the more elegant, and see how those subtle tweaks can really make a big difference in terms of performance.
Absolutely.
But before we get ahead of ourselves, let's just make sure we're all on the same page here. Like, how would we even begin to calculate this string score?
Well, let's take a simple example. Let's say we have the string cat.
Okay, cat.
So each of those letters, each character, has a corresponding ASCII value, right?
Right.
So C is 99, A is 97, and T would be 116.
Okay.
Now, to get the string score, we look at the absolute difference between each pair of those adjacent characters.
Oh, okay, I see. So the difference between C and A would be 2.
Right.
And then A and T, that's a bigger jump, that's 19.
That's right.
And then we add those together,
Add them up.
2 plus 19, and we get a string score of 21. Pretty easy, right?
Absolutely. You got it. You've got the core idea.
Straightforward.
Yeah. Now imagine you're dealing with a much longer string, maybe a paragraph, maybe a whole page of text.
Right, right.
Trying to calculate the score manually by comparing every single pair of characters would just be, well, it'd be really tedious and inefficient, wouldn't it?
Yeah, it'd be like trying to count grains of sand on the beach or something.
Exactly.
There's got to be a better way, a more systematic, a more efficient way to do this.
Yeah.
What if we tried a brute force approach first, just to get a feel for the problem?
I think that's a great starting point. Yeah.
Okay.
So in a brute force solution, we'd probably use a loop
Right.
to go through the string.
Yeah.
And for each character, we'd grab the ASCII value of that character and the ASCII value of the next one in line.
Okay.
Calculate the absolute difference between them, and then we add that to a running total.
So it's like we're taking this like a step-by-step walk right along the string.
Yeah.
And we're just keeping this tally,
Yeah.
right, of the jumps in ASCII values between each of the letters.
That's right.
It's intuitive, but probably not the most optimized solution, would you say?
Yeah, you're right. I mean, a brute force method would work. It would definitely get you the answer.
Yeah.
But as the length of the string grows, it might start to struggle.
Okay.
Because we'd be revisiting parts of the string multiple times, and we'd end up doing a lot of redundant calculations.
Yeah.
It's not ideal.
Okay, so that's where this idea of a single pass solution comes in, right?
Exactly.
Can you give me a hint? Like, how would we even begin to tackle this problem in a more elegant way?
Okay, so think about how we could calculate the score as we're moving through the string.
Right.
Without needing to backtrack or revisit characters we've already seen. It's like you're keeping a running total in your head, and you're updating it with every step you take along that string.
So instead of calculating the difference for each pair and then adding it to the total, we'd keep a cumulative score as we go?
You're getting warmer. Think about, how would you initialize that score? What operation would you need to perform at each step to make sure you're accumulating those absolute differences correctly?
Okay, I think I'm starting to see it. We can start with like a score variable, set it to 0.
Okay.
And then as we're looping through the string, we grab the current character and the next one, calculate their absolute difference.
Right.
And then add that difference directly to the score.
Yes.
So by the time we reach the end, our score variable holds the final result.
You've got it. You've nailed the core concept of the single pass solution.
Yeah.
It's all about going through that string just once and accumulating the score efficiently as you go.
This is already feeling so much more streamlined than the brute force approach.
It is, isn't it?
But before we get into the nitty-gritty, the details, are there any like common pitfalls or gotchas that people might run into when they're they're working with this problem?
Yeah, there are a couple of subtle but important things to keep in mind. One is that when you're looping through the string, you need to be careful not to go out of bounds.
Out of bounds, what do you mean?
Well, since we're always peeking at the next character,
Right.
you need to stop your loop one character before the very end of the string.
Oh, I see.
Otherwise, you'll be trying to access a character that doesn't exist,
Yeah, yeah.
and that could cause errors.
Right.
So it's a small detail, but it's an important one.
It's easy to overlook those boundary conditions when you're so focused on the logic of the whole thing.
Absolutely. And another potential pitfall is forgetting to take the absolute value of the difference.
Oh,
Because remember, we always want to be adding a positive value to our score, regardless of whether the current character or the next one has a higher ASCII value.
yeah. Otherwise, we might end up with a negative score,
Exactly.
and that wouldn't make sense.
It wouldn't accurately reflect the total difference. So those are just a couple of things to watch out for.
So we've laid the groundwork here. We've identified some potential pitfalls, and we've even hinted at this more efficient single-pass solution.
We have.
Where do we go from here?
Well, I think it's time to unpack that single pass solution in more detail. We can break it down step by step.
Okay.
We'll even look at how it compares to other methods like recursion, maybe even touch on dynamic programming.
I'm ready. I'm ready to dive in. This is where it gets good.
Let's do it.
All right, let's break down the single-pass solution. You've been hinting at it, so I'm all ears.
Yeah, it's all about efficiency, right? And elegance.
Mhm.
So picture this. You've got like this imaginary pointer moving across the string,
Oh.
one character at a time.
Okay.
And at each position, it grabs the current character and kind of peeks at the next one,
Right.
calculates the difference in those ASCII values, adds it to like a running total, and then moves on.
Right.
It's like a smooth, continuous process.
So we're not like jumping back and forth between characters. We're just we're gliding through it, accumulating that score as we go.
Yeah, exactly. That's the essence of it. Now, to make this a little more concrete, let's talk about pseudocode,
Okay.
which is like a blueprint for our solution.
Right.
So we start by initializing a variable, we'll call it score, and we'll set it to 0.
Okay, so score starts at 0.
Yeah, like an empty bucket waiting to be filled.
Got it. What's next?
Next, we set up a loop that will run through the string, but here's the catch. We have to stop one character short of the end.
Oh, right, because we're always peeking ahead to the next
Exactly.
character, so...
We don't want to fall off the edge.
Right, we don't want to get that index out of bounds error.
Exactly. So inside the loop, for each character, we do 3 things.
Right.
First, we grab the ASCII values of both the current character and the next one right next to it. It's like taking 2 quick snapshots.
Got it. Snapshots. Okay, so we have those 2 ASCII values.
Yep. Then comes the calculation. We find the absolute difference between those 2 values, so we always have a positive number.
Right. We're measuring the jump between those characters, but the direction doesn't matter.
The magnitude is what matters. And lastly, we add that freshly calculated difference to our score variable, updating that running total.
So we just keep looping, grabbing characters, calculating, updating, and by the time we get to the end of that loop, score holds our final answer.
You got it. It's elegant, isn't it?
It is.
And it's remarkably efficient. Think about it. We're only going through the string once,
Mm-hmm.
which translates to a time complexity of O(n), where n is the length of the string.
So if we double the length of the string, it just takes, roughly double the time.
Pretty much.
Okay, that's very manageable.
Yeah, very scalable. And what's even better is the space complexity is O(1),
Okay.
meaning we're only using a fixed amount of memory, regardless of how long the string is.
So we're basically working in place.
Working in place, exactly.
This is a powerful combination, both time and space efficient.
Yeah, it is.
But I am curious, are there other approaches to this problem? I know you mentioned recursion
Yeah.
and dynamic programming earlier.
We can explore those, definitely.
Yeah.
I mean, there are always alternative paths.
Yeah.
Recursion, for example, it's a really elegant way to break down a problem into smaller, self-similar subproblems.
I mean, recursion can be a little bit mind-bending at times, but I'm intrigued. How would we apply that to this string score problem?
Okay, so imagine we have a function, we can call it calculate score, and it takes a string as input. Now, the base case, the simplest scenario, is when that string is either empty or has just one character.
Okay.
In that case, the score is 0 because there are no adjacent characters to compare.
All right, so that's our starting point. What happens when we have more than one character?
That's when the recursion kicks in. We'd calculate the absolute difference between the first two characters,
Okay.
and then we would make what's called a recursive call
Mm.
back to our calculate score function. But this time, we feed it the string, but with the first character removed.
Oh, I see.
So we're shrinking the string with each call,
Yeah, yeah.
calculating the difference along the way. And each time we make that recursive call, we add the calculated difference to the result of the call itself.
So it's like we're building this chain of calculations.
It is. It is. And eventually you hit that base case where you have a string with just 1 or 0 characters, and then the whole thing unwinds and you're left with the score.
Okay, that's pretty neat. But how does the efficiency of recursion compare to our single pass solution?
Well, recursion, it's elegant, but it often comes with a little bit of overhead
Okay.
because each recursive call adds a new layer to what's called the call stack, and that can use up memory, especially if you have a really long string.
So it might not be as space efficient as the single pass solution.
That's right, because the single pass solution is essentially working in place. In terms of time complexity, they're both generally O(n), but recursion might have a slightly higher constant factor because of that function call overhead.
I see, I see. But sometimes, it's not all about raw speed, right?
Right.
Sometimes readability of the code, how easy it is to maintain, those are important factors too.
Very true.
And that's where recursion can really shine, I guess.
Absolutely. It's like choosing between a sleek sports car and a reliable workhorse.
Yeah.
Both will get you there, but they have their own advantages.
Exactly. And then we've got dynamic programming. You mentioned that. That takes a different approach altogether.
It does. It's all about storing and reusing the results of those smaller subproblems to avoid it doing the same calculations over and over again.
Okay.
Now, we didn't strictly need dynamic programming for this particular problem,
Right.
but it just highlights a really powerful optimization principle, something to keep in mind for more complex challenges.
So we've really journeyed through all these different approaches to this string score puzzle from the brute force to the single pass.
Yeah.
And even dipped our toes into the recursive waters.
Yeah, it's like we've assembled a mental toolkit
Yeah.
equipped to tackle this challenge from all these different angles.
And what I find so fascinating is that, this problem that seemed at first glance so simple, calculating string scores, has actually exposed us to all these broader principles like time and space complexity, the trade-offs between different algorithms, and we even touched upon optimization techniques like dynamic programming.
Yeah, it really is a microcosm of what makes algorithmic thinking so powerful.
Mm-hmm.
You start with this very specific problem, but the things you learn along the way have these ripple effects across
Right.
your entire approach to coding.
It's about recognizing patterns, understanding the strengths and weaknesses of different tools, and then choosing the best fit for the job at hand.
You got it.
So if we were to step back and compare these different approaches, what are the key takeaways? When would you reach for a single pass solution versus, say, recursion?
Well, if raw speed and efficiency are your top priorities, the single pass solution is 9 times out of 10 going to be the clear winner.
Mm-hmm.
I mean, it's O(n) time complexity and constant space complexity. It's hard to beat, especially when you're dealing with those really large strings.
That's like a well-oiled machine, just going
Right.
through the data and not wasting any steps.
Exactly, exactly. But that being said, don't dismiss recursion entirely,
Yeah,
because it has its own beauty, especially when the problem just lends itself naturally to that kind of breakdown.
right.
If you value code elegance, readability, recursion can often produce a more concise and just aesthetically pleasing solution.
Yeah, it's like choosing between, a tool that's just really sharp and efficient versus one that's just beautifully crafted.
Yeah.
Both have their place, I guess.
They do. And then, of course, there's dynamic programming kind of lurking in the background,
Yeah.
ready to swoop in when we have, when we're faced with those problems, with overlapping subproblems,
Right.
and the potential for all those redundant calculations. We didn't really need it for the specific challenge,
Right.
but it's still a really valuable tool to have in your coding arsenal.
It's like having a secret weapon ready to be unleashed when the time is right.
Absolutely. And I think the key takeaway here is that there's rarely a one-size-fits-all solution in the world of algorithms.
Yeah.
It's about understanding the nuances of the problem, considering the trade-offs, and making those informed decisions
Mm-hmm.
based on what your priorities are.
This has been a fantastic deep dive. We've not only learned how to calculate string scores, but we've also gained insights into different algorithmic approaches, their strengths, their weaknesses, and really the art of choosing the right tool for the job.
Couldn't have said it better myself.
Well, what's even more exciting is that these concepts, they extend far beyond this specific problem.
Oh, absolutely.
Think about any scenario where you're dealing with sequences, with patterns, with cumulative calculations. The principles we talked about today, they can be applied in so many different contexts.
It really can.
That's the beauty of exploring algorithms, right?
It is.
They're like these fundamental building blocks that we can use to construct really elegant and efficient solutions to a wide range of challenges.
So true. So as we wrap up our deep dive here on string scores, I'll leave you with this thought.
Okay.
Next time you're facing a coding problem, take a step back. Consider those different paths you could take. Could a single pass solution streamline your code? Would recursion be a more elegant approach? Is there a way to leverage dynamic programming? The more you explore these options, the more powerful your coding skills will become.
That's a fantastic challenge. Thanks for joining us on this deep dive into string scores. And until next time, happy coding, everyone.
Happy coding!